Hey everybody, thanks for joining us for another live video on Facebook, YouTube, and at Eastwood.com. I'm Randy here in the Eastwood garage. Today we're talking about the mp250i multi-process welder. So of course we have the product manager for this welder with us, Andy. So Andy, we sell a lot of welders, MIGs, TIGs, multi-process units. Who's the guy that's going to need this mp250i?
It's going to be anybody from the weekend fabricator, almost the DIY, all the way up to the professional. So he's going to want to be able to MIG weld, which is basically your standard operation, stick weld, if he ever runs out of gas or if he's just doing a project where he doesn't have the ability to have gas, flux core, which we can't forget about that. If it's a MIG welder, it is a flux machine. We'll talk about the drive roll later, very good with flux. And also TIG, so scratch start DC TIG. So if you're working on a project where you're doing MIG welds all day long, but you want to make something real pretty, you break out the TIG, or if you're just trying to learn, you don't want to buy thousands of dollars worth of TIG machines, you can get started with this and eventually get into one of our AC/DC machines or get into the new digital.
Or if you're somewhere where you don't have gas, you got the stick welding option, and you can get a spool gun with this.
Yeah, absolutely.
I mean, we sell them separately, but you do have the option to get a spool gun and weld.
Yeah, so you technically can weld every material.
All right, so let's quickly, we want to get into some serious welding. We're going to be welding sheet metal, 1/4 inch, 3/8, but while we're doing it, let's quickly go over some of the features of this unit.
So it's a fairly easy machine to start up.
Should we turn it on?
We will. So we'll let it kind of warm up here for a second. Really easily to look over this machine, you see white icons. So wherever there's a white icon, that means it's in MIG mode. So right now we're in MIG, and you can see up here you've got either your torch or your spool gun.
Okay.
So if you ever want to move over to your spool gun,
The touch of a button.
touch one button, and then you'll obviously swap out your cables to move over into the spool gun. But for today's video, we're going to stay on the MIG mode. But as you can see, like I said before, you have 2T and 4T. They are white icons, so that's what can be controlled by
we have the
MIG.
torch here. We can show. If you're not familiar with 2T and 4T, it's simply 2T is
your normal process. So it's two touch. You're literally pulling the trigger 1, letting go is 2. And as you can see, the started feeding right there. If you go over into 4T, you click in and out, and it will start welding. And to stop, you click it again.
We were actually earlier we were actually doing this. We have some footage to show you just some basic welding. So you can see you release the trigger and it continues welding until you hit the trigger again, and that's what turns it off.
Correct.
So it's great for hard to reach areas.
Yeah, hard to reach areas if it's incredibly hot. So in some cases, you're going to be spray transferring, which is what we're going to do here in a little bit.
Yeah.
After a couple seconds, you're using your full 250 amps.
Well,
if you don't have the gloves for the job, it's going to really, really warm up your hands.
So you can pull back.
Yeah, you can kind of move your hands, readjust, keep welding, not to worry about your finger being on that torch the entire time on the trigger. Which is another good thing is we do have an awesome torch where you don't have to be all the way up here. You can grab down here on the little end trigger and get in better, more comfortable position.
And speaking of heat, 60% duty cycle at the full 250 amps.
Yep.
So you're going to be able to weld a long time.
And it's 100% just under 200 amps.
Yeah, at 194 amps, you get 100% duty cycle.
Most of us are not going to be ever there, and that's also at 104 degrees ambient temperature. So honestly, if you're out in the desert, that's where the duty cycle is. But today in our shop, 65 degrees in here, it's basically 100% at full 250 because of the ambient temperature.
So, all right, so we got to get welding here in a minute, but let's go over, so we just went over MIG. We got inductance, which we're going to show you. We're going to get to that in a minute. We've got the wire speed and voltage. Wire speeds from 78 all the way up to 629 inches per minute. So now if you want to go to TIG or stick, how difficult is that, or how easy is that?
So all you're doing to switch over to, we'll start with TIG. You literally push one button, now you're in TIG mode. So, and
then you just swap out. We've got the TIG right here.
So all you're going to do is, depending on, well, with TIG, you're going to be an electrode negative. So you're going to go down here, you see your negative.
Yeah.
You're going to pull your ground out. You're going to pull your torch cable lead out. And you're going to plug in your TIG torch. You're going to plug in your ground into positive.
And it's that easy.
And you're going to hook up your bottle and you're going to go.
Yeah.
So when it comes to arc mode,
well, we have some TIG welding earlier. Oops. There we go. We have some TIG welding from earlier. I mean, to show how easy it is, because really today we want to get into MIG welding.
Yep.
But we have, because you can TIG weld up to 5 30-second with this.
Correct.
Yeah, so if you're looking to TIG weld steel, you know, you'll be able to do 5/32 with this machine, or you'll be able to TIG weld, you know, if you want to learn how to TIG weld, this is the machine, you get it, you can MIG weld, and then, you know, and practice TIG welding while you're at it. So now arc, very similar
welding,
setup.
Yeah, you're going over the exact same thing, so you're going to click this again.
All right.
And then depending on your electrode you're going to be using, 7018 you want to be electrode negative.
Okay.
Some other ones you want to be electrode positive. So depending on that, you're going to plug in your ground to either the positive or the negative. Because we're going to be MIG welding here in a minute, I'm going to plug the negative back into the negative.
And all of these leads here, they're all 15 feet long.
Correct.
Whether it's for stick welding, TIG, or MIG.
Yep.
So with 15, so then you would just, again, you just plug it in, and you're set.
Yeah.
That easy. And like I
Select
said,
your electrode and then start welding.
15-foot lead. That's really crazy. I mean, that's great when you're working on a project. You don't got to keep moving your welder. I mean, you can make it the whole way around the car.
Yeah.
Just because your leads are 15 feet long.
That's probably the #1 complaint we've had in the past, was that the torch isn't long enough, the ground isn't long enough, which is the reason why we brought out ground extensions.
Okay.
So in many cases when you're using our plasma cutters, you have incredibly long torch, but your ground cable is a little bit shorter.
Yeah.
So in order to get to a project, you can get a ground extension from us. Or with this machine, now you got 15-foot cables on all sides, so MIG torch, TIG torch, and electrode cable, all 15 feet, and your ground. So your ground's not disproportional, they're all 15 feet, and then your cable for the power is another 10. So you can get 25 feet away from your wall socket without even having an extension cord. That's more towards the guy that professionally working on cars, but let the DIYer have it too.
Oh yeah, absolutely. So, all right, let's get started welding. Now first, everybody, if you're familiar with our live videos, you can ask questions. We encourage it during them. We have Scotty over here, who many of you know, our lead tech. He's going to be answering questions during this entire live stream. He's going to be throwing some of them back to us, so Andy can answer them live. And let us know what you want to see. We've got, like I said, we've got sheet metal, 1/4 inch, 1/8 inch, 3/8. We're going to be welding it all.
Yeah, T-joints, butt joints, lap joints.
So
let us know what you want us to weld. I mean, we're going to go through as many as you want us to do. We're going to start out with spray transferring.
Yeah, let's start off with the serious.
Yeah.
Let's not work our way up. Spray transfer. That's what everybody wants to see.
If you guys haven't seen it yet before, it's not that normal sizzle.
Yeah.
Like the bacon crackling, and then a whole bunch of slag everywhere.
You can tell instantly when it goes into the mode.
It's very, very different. And because of the way we're doing this, this thing is maxed out. It's going to be all the way up to 250 amps. We do only have 035 wire in it right now. You can put 45 wire in it. So we could do 1/2 inch spray transfer right now, but since we only have 35 wire in it, we're just going to do 3/8.
Okay.
We just don't have enough wire to really fill this joint.
3/8 is still pretty thick.
Yeah. So what we're going to do is we're going to do 3/8 and we're going to do spray transfer. So the machine's maxed out, and we have it set up to 400, almost 80 inches per minute.
Okay.
That's a lot of wire.
That seems like a lot of wire.
It is, but that's what you need to do for spray transfer. You really need to force a lot of material in there.
That's
and
like
more
12,
wire
13 feet a minute.
It's moving a good amount.
Some wire.
And I am actually going to put on some stick welding gloves.
Okay.
Because this is going to get very, very hot very quickly. But surprisingly, it's very clean.
Okay.
You're not going to see a whole bunch of sparks.
And we're going to let Joe. Move around. If you're familiar, we do this a lot in TIG welding, so you can really see it. We also do it in MIG welding, where we have Joe get in position, puts a special, basically it's a welding lens over the camera. Yeah, we don't give away all of the secrets. So that way you can see what this looks like. And don't forget, if you have any questions, Scott's over here to answer them, and we're really going to get into welding now. So I'm going to let you get started. I'm going to step off for a minute.
All right. Come on over, Joe. At first, you might hear a little bit of the crackle, but it'll get into almost a hum. What we're going to do is just get started, and as soon as Joe's ready, we'll get moving. Good to go, Joe?
I'm good to go.
All right.
Wow, you can really see that. That's pretty impressive. It's amazing how it goes almost silent.
Yep. And that crackling was actually the material being like slightly dirty.
Wow, look at that. That's pretty sweet.
So instead of having that normal ripple that you would see, it's just a straight line all the way across. And the reason why you didn't see me doing like the little E's or going back over my weld is because what you're doing there is you're actually changing the distance of your nozzle to where the actual welding surface is. So you want to keep it at the same spot. That way you keep that humming the entire time. As soon as you'd kind of move closer or move further away, it would actually change the arc a little bit and you wouldn't be in that constant state of spray transfer.
Oh, so you want to keep it to where everything is you're running at that same distance the whole way.
Correct. And with something that's this thick, you want to do a root pass anyways. So you don't want to be weaving in and out. You want to be right there in the deepest part of the weld. And then eventually, if you really want to get a lot more weld on there, you can come back, do a weave over top.
Would you do one big weave over top then? Or?
It depends on the joint you're doing.
Okay.
So with this, since we only have 35 wire, I might do 2 more over top of that. One up top, one on the bottom. If I had 45 wire, it might be just one.
Okay.
It all depends on what amount of material you can put into it.
Man, you can really hear that too.
Yeah, so I'm not going to want to touch this thing anytime soon. Earlier, we were doing some spray transferring before and got to the point where the entire piece was glowing red, so we want to
move that out
not put our hands on that one.
So what else should we weld? Should we turn it? Should we go the complete opposite all the way down to sheet metal right now?
Yeah, let's do it.
All right. We're going from 3/8 to sheet metal. Turn the machine back on.
Yep.
Scott, do we have any questions?
From LB, and he's asking, one, if you get a close-up of the gun, and also how big of a roll can it hold?
Great question. So this machine can hold anywhere from an 8-inch to a 12-inch spool.
We can get
so if you guys aren't familiar with that,
we just have an 8-inch here now.
Yeah, that means up to a 44-pound spool. So
yeah,
it's a lot of wire. But as you said before, it can move a lot of wire. So in that way, you have the ability that you go out, you buy, say, a 44-pound spool. You might not have to touch that for a year if you only do weekend fabrication.
Should we
but
show
a lot
them,
of pros will
should we show
use
them
one
the
of those
gears
spools.
here?
Yeah, absolutely.
All right, it's got double. I don't know if you want to. Joe, can you get in? Can you see? Maybe let me turn it a little bit more. We need to see. There we go. Right here, right?
Yeah, so a little bit different than our other machines, which you only see a single drive roller. With this machine, you're seeing 2. So you actually have 2 adjustments, and they are bound by gears. So
metal gears.
Yeah, with metal gears and quick change. These are double-sided, so all you have to do is just unscrew these little guys, pull them out, swap them to the other side, and then you can change the size wire you're using, and then you tighten it back down. This isn't any some just random plastic drive roller.
And like all of our welders, got a chart here that makes it really easy to set it up.
We've spent a lot of time on this chart.
MIG, TIG, and ARC.
Literally went through every single process, every single thickness on all the different wires, and made sure that we've done it and we know this is going to work well for you. So it's anywhere between MIG, flux core, TIG, also into stick welding. If you get into our manual, it actually shows you each side of electrode and what type of electrode. So,
so you really
if you are familiar with stick welding, there's 6011, 6013, 7018. There's tons of different ones.
Yeah.
We go through the different thicknesses. We go through the polarity and basically get this machine set up absolutely perfect. So you don't have to call Scott.
That's good. All right. Oh, and they want to see the gun before we get back welding, right? I want to see the torch for this one.
You want to come in here? So this is something else that we've had a lot of guys seen other machines and say, oh man, that's a cheaply made torch. This isn't. This is a Binzel torch. It is the Ergo Plus 24, so it's our tried and true with the MIG 250 that we already have out now, which is kind of a lighter machine, but with the same duty cycle. That thing's a beast too. But for the guy that wants to put a bottle on the back of the machine and be able to do more processes, that's what this thing can do. But we're using the same gun because we've got a lot of praise over it. Very, very high duty cycle that matches the machine. And also to be able to work very quickly, you can pull off the nozzle, which I'm going to grab a glove real quick just in case this thing's hot. Instead of screwing it off, you can just pull and then quick clean out the inside of your nozzle. We have all these set up in consumable kits because we already have the 250 out. So you can go anywhere from down to 23 wire up to 45. You know, quick change out everything and not have to sit there with a tool and try to redo all that stuff. You can just pull the thing right off really quickly. Something that I really like, we talked about earlier, is I don't like to have my hands up here on the gun. I like to have my finger all the way back on that smaller area. That way my hand's a little bit further away.
Yeah.
I don't get, really hot hands. I like to use TIG gloves on MIG, but at the same time, they're only good to a certain extent when it comes to heat and spark. So I like to have my hands a little bit farther back. And this makes it a lot easier on my hands, especially with a little bit larger gun to match the machine.
Cool. All right, well, let's get into, let's weld some sheet metal.
All right, let's turn this bad
If you're
boy
just joining us, we were welding 3/8, or Andy was welding 3/8. So we're going the extremes here. Oh, and the other thing is that really, if you want to weld sheet metal, this has an adapter cord, so you could plug this machine in. The adapter cord's on there. We have an adapter cord, so it adapts from a 240 volt plug down to 120. So you are able to just plug this in 120 volts. You won't be welding 1/2 inch thick metal, but it is good if you want to weld sheet metal. But we're going to show you don't even have to do that. You can still operate on 240 volts without the adapter cord, dial it down, tune it in, and weld some sheet metal.
So we're just going to do some quick stitch welds, basically.
So you got to turn down to 18 volts.
Yep. We can go down lower.
Okay.
But since we do have 35 wire in,
Okay, yeah.
we want to be a little bit hotter just because it takes a little bit more to actually burn this wire. I would suggest I personally like 30 wire for doing sheet metal. I know Mark back in R&D likes to use 23 wire.
Yeah.
It all just comes down to your preference. You can use the big wire like we are today, just because we don't want to be sitting here changing over things while you guys are watching. We want to quick get into welding, and 35 wire will work.
All right.
So we'll get into it right here.
Let's check it out.
Fairly simple, just did a couple, quick little guys. Something that I want to get into, I actually had the inductance up all the way. So we want to talk about that real quick. Just to explain, if people don't know, inductance is actually when the weld short circuits. So if you ever take a weld, and maybe someday when we get a high-speed camera, we'll be able to show you guys this. But what happens is it short circuits. So you have the wire actually melts and creates that puddle.
Okay.
And with inductance, you control how that happens. So if you turn it all the way down, technically the frequency of that short circuiting happens more often. So the frequency goes up.
So it's boom, 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 boom.
Yeah, it's quicker than it normally would be.
Yeah.
So when you turn the inductance up on this machine, it's not necessarily that it happens more frequent. The duration of that short circuit is longer.
Okay.
So think of it as, instead of a dot, it's more of
like a longer
line.
pulse. So it's boom.
Yes.
Hits.
Correct.
Releases rather than
And what we're going to do
bouncing.
later is we're going to show you what the difference between those two are actually in the material. But where this is important is with inductance all the way up, you're going to get a nice wide heated puddle. With it all the way down, you're going to be able to pinpoint your arc.
Okay.
So it's not going to get really super deep, but when it comes to sheet metal, and you want to get into a really tight area, and you don't want to have it too wide, something that you're going to have to grind down, you turn it all the way down, you have a really, really nice small bead.
Okay, like
something
like
we can show here. So right on the back of it, this is with inductance all the way up. This is with inductance all the way down. So you can see the difference. We could show you in the front the difference all day.
So this is all the way down. So that means
that pulse was longer.
Longer
basically.
pulse. It's not as frequent.
Correct. So
Okay.
it's a nice wide flat puddle, for these little spot welds, which is great, but not necessarily what you want all the time. So if you're butt welding two pieces together like we were over here, you might not want that because you might blow through. So if you actually make it so that at a higher frequency, you get real precise in that small little crack. You don't have to do much grinding, and you don't want to have to do much grinding on sheet metal. As you can see, we did a ton of little tests earlier, but to make it really easy, you guys can see that the heat mark on the back is substantially larger than it is when the inductance was turned very low.
Now, would this really come into play if you're, say, doing a butt weld as opposed to a T-joint or something? Would you want to use one over the other there?
Yeah, when you would do
I
would say when you need a butt weld, you would probably turn it up. You would want a little bit more heat because you want to get deeper into that weld.
So you would have the longer pole, not as frequent, right?
Correct.
Okay.
Yeah. And also on.
So when it's turned all the way down, you have less frequency, but you're going to have more heat.
You actually have more frequency down.
Okay, so you turn it all the way up, you have
heat.
less frequency, but you got more heat.
Correct.
So you'd want that in like a T-joint, probably.
Yes. Yep.
Okay.
Yeah. So something we'll get into in a minute. We'll show you the difference.
So it's a cool feature to really improve your welding if you want better based on the joint you're having.
Inverter machines, it's a lot easier to have that. Old transformer machines, it's not as easy to accomplish that. Something we can show you before we actually show you how that happened. This was inductance all the way down, so we can show you the weld all day long, but the real truth into what's happening is the heat mark. So this is with it down, so you can see how precise that is.
Yeah.
Some cases that's good. Sheet metal, you'd want that. You wouldn't have as much warpage with sheet metal if you did that.
Okay.
So with it turned all the way up, you can see that heat transfer mark is almost through the entire piece.
So so thicker metal? Is that okay.
I would suggest for thicker metal. Yeah, we'll put them up class.
Yeah.
You want to quick ask any questions?
Do we have any questions, Scott?
I know we didn't cover the size bottle we can hold, which is pretty important.
The question was, what size bottle? We've got a small bottle on it, but what size bottle could you actually put on this?
The 330 CF bottle.
Like the 6 foot tall one?
Correct.
I mean the 6 foot tall one.
So what we do around here is we have a lot of the smaller ones because we know that a lot of our customers are the DIYers.
And it's got 2 chains for when you have the big bottle.
So currently we've got an 80 cubic foot bottle on them, but we know there's a lot of guys out there that you rent or inherited a big bottle and you just go and get it swapped out every time you go to your local welding shop. So you can use that massive 9-inch round bottle. We know a lot of guys that have given us that feedback. Man, I wish I had a cart that could hold that bottle.
Yeah.
Now you got a machine that holds its own bottle, and it also can hold
it's
your TIG
all
wire
in
and
one
everything
here.
like that too. So easily moved around, that sort of thing. And you load it right on, very low shelf. That way you're not sitting there struggling trying to lift that 330 cube bottle. So
yeah,
a little larger than what we have here, but we know there's guys out there that use them.
So what else are we gonna weld here?
We can do some T-joints, some 1/4 inch. We can do some 1/8 inch, lap joints, whatever we wanna get after. We'll move
let's do a T, a lap, and a butt joint. What do we say?
We'll start out with, let's say, the 1/8 inch. So let's get it set up.
Are we doing it? We have some footage. I mean, we were doing stick welding earlier.
Yeah, right now we don't have any electrodes out here.
We have. We could probably show some. Yeah, we got some stick weld. I mean, it's like I said. If you're just joining us, it's just connecting a couple leads.
Yep.
And switching over. It's really simple to start TIG welding. With this machine. We were like I said, we were doing it earlier. We were TIG welding earlier. But today, I guess we're concentrating on MIG welding since that's what the majority of the
people as an automotive enthusiast, and that's basically what our company's based on is to support those guys. And we're trying to get out to the big fabricators possible with these guys. But
sheet metal to bridge building with this one.
Working on an excavator or something like that, you have the ability to do that. Or if you ever run out of gas, you can switch over to arc welding. I know a lot of guys say they're building a frame of some sort. They have to finish their job that day.
Yeah.
You run out of gas, and maybe your local welding store just isn't open on a Saturday or Sunday.
Yeah.
Or they close at 5, and you work until 5, 6, 7 o'clock at night. You just don't have the option to get it swapped out. So you have to get the weld done.
There it is.
Arc welding.
Cool.
So
T-joint, we got about 1/8 inch.
Yeah, right now this is
so we're going to turn it down.
Fairly on the low side of our machine that we're normally doing.
Yeah.
You already saw us do 3/8. Saw us do a couple little spot welds. Now we're going to get into...
Oh, Joe, you going to come in again? All right, we're going to bring the camera in again even. Cool.
Wait for him to get over here.
Oh.
We're going to hop right into it. All right. Good to go, Joe?
Look at that.
A little toasty,
You
but...
may not want to go anywhere. You getting hot there, Joe? You want to stay back on the next one? We've got a couple shots of well on it.
Yep.
Let Joe cool off. So, what do you want? So we're gonna move on.
Yeah, fairly simple one. If we want to
Flip
show
that
this...
around so Joe can see it.
Flip these guys around. And then once that cools a little bit, we'll be able to show some of the heat transfer, you know, for you guys on the back end. Trying to get in the best angle possible. You know,
we
with
turn it
Joe
around
kind of
over
on
here?
my... Yeah, well...
Yeah, you
Got it, Joe?
Got it.
Look
So
at
you
that.
can see it's, I mean, the heat transfer all the way across. Right where we started, it's a little bit lower because obviously the actual metal eventually comes up to a certain temperature. But as you can see with, you know, lesser welders, you're going to get kind of an uneven, you know, heat transfer all the way across. We've got a nice...
And lesser
even
welders,
one.
you mean the machines?
Yeah.
Not compared to you.
I mean, I don't know what I'm doing, so. But we can jump right into 3/4. We can do lap joints. We can do you know, some flat welds, answer some questions, or just hop right back into it.
Let's jump into something else.
All right. What I'm going to do real quick, if nobody has any questions, is I'm going to do the same thing I did over here with the inductance. That way you guys can hear the difference because of the frequency change.
Are you going to go like half and half? Can you weld them together half and half, or are you going to do two pieces?
What I want to do is I want to do two pieces
Okay.
because what's going to happen is once we get this thing warmed up, you're not going to see the exact difference because the piece will already be warm.
Okay.
So I want to make sure that this piece is cool over here.
Okay.
I'm going to do this weld.
So it's a good comparison.
Yeah, that way I can put it away. I mean, I did a couple earlier where I ran one into another basically. You could see a little bit of difference, but you couldn't see the heat difference.
Okay.
You couldn't.
Yeah.
I want to make it so these guys know the difference.
Yeah,
so
they
what I'm
can
going to
see it.
do is I'm going to turn this thing all the way down. This is going to be the one where your frequency is going to
turn
be
the
higher.
inductance all the way down.
Yeah. Inductance down means frequency higher of...
So more frequency.
Yeah, more frequency of the short circuiting of the arc itself.
All right.
So we're going to get right into this.
And you don't have to remember all this. We have a chart.
Correct. We
And
do have a chart. So I'm going to turn up the machine a little bit since we're doing a little bit thicker material now. Let's see. Actually,
Now, do we want to get Joe in here for this?
This is going to be
or is this more
even a little bit
afterwards?
hotter. So Joe can stay back a little bit.
Okay.
But we'll just quick do this. We don't need to do a full length, but we'll come back. We'll do the other one. We'll do them fairly quickly in succession. That way you can hear the difference.
Okay.
And we'll talk about the results.
Cool.
All right, we're going to quick jump over, change it all the other way.
Now this is with the inductance turned all the way up.
Yeah, now it's turned all the way
Less
up.
frequency.
We're going to jump
So
right
this will
into
be more heat, technically, concentrated.
Correct, yeah.
All right.
You
Now,
probably hear that difference.
Was there less spatter with that, or is it
Substantially less.
because there's more heat going into that area? Is that because the inductance is turned all the way up? You end up with
So
less
with that
spatter?
short circuiting, because it's switching back and forth to
Yeah.
basically the pulse in and then out, every time that switches, you kind of send sparks.
Okay.
So since that's technically happening less,
Less.
and there's more arcing of itself, you're getting less. So it's going to be
Okay.
technically a cleaner weld. These pieces aren't the cleanest thing in the world. We did a
Yeah.
little bit of prep before the fact, but as you saw earlier,
Yeah. I mean, you can definitely hear it and see it. Oh, yeah.
so it is a little bit different. I was a little bit faster on one than the other, but the best example was earlier where I timed them was going to be low inductance, high inductance, but you could definitely hear the difference.
Yeah. Oh, yeah. You can easily hear it.
Yep. So we can move on to some others, answer
Yeah,
some questions,
do-
or
Any questions there, Scott?
Two questions would be, what's the minimum thickness you can weld with this unit, and
Oh.
what's the maximum you can weld with this unit?
The minimum thickness? Well, on MIG welding, the maximum is 1/2 inch.
yep,
And the minimum is, we're just welding, I mean, Andy was just welding sheet metal. And like I said, he was welding with it on 240, not the ideal wire, no problems at all. So, I mean, you can
This
even
is
turn the
what, 20
voltage
gauge?
down. Yeah. Yeah, so it's 20 gauge, it's 20 gauge sheet metal.
yeah,
So we went from 20 gauge sheet metal to 1/2 inch thick with the MIG. TIG is 5/32. You can weld up to
Yep.
that, or sheet metal. And stick welding is what, 3/8?
yeah. 3/8. It all depends on the electrode you're going to be using. I mean,
But-
honestly, you turn it all the way up to the top, and you can do 3/8 all day long.
The MIG was really impressive. I mean, really, we started off with that 1/2 inch spray transfer.
Yep.
And then a minute later, you're just welding sheet metal. And we didn't change the wire. We didn't switch to 120 volts, which we
No.
could with this machine.
Yeah, this is a dual voltage
Yeah.
machine. So if you're just getting started, you don't have 220 in your house
Yeah.
quite yet. Honestly, you can use this all day long on 120 volts. And by the time you get the electrician over to your house to set up the full
You're
big
ready
boy
to go.
voltage,
The big boy voltage.
I mean, not everybody
Yeah.
has the option.
Yeah.
So that's why a lot of our machines are dual voltage, and it gets you into a bigger machine that you can grow with. I love this machine because it gets you everything you need, for stick,
Yeah.
TIG, and MIG, and the spool gun, if you buy the spool gun, which is optional.
You can do aluminum.
Yeah, and you can take it over to a buddy's house if you absolutely need to. I mean, you're obviously going to want to keep it at home. But if he only has 120 and you need a job done, you can take it with you.
Cool. So now what are we going to weld?
And it's lighter than you think it is. it's under this machine without the
It's
bottle.
under 100 pounds.
Yeah, this
Yeah.
machine without the bottle on
Yeah.
the back is under 100 pounds.
Yeah, it's not like the welders you see from a few years ago where
Yeah, there are a lot of
Would've taken
welders
a-
out there that look
crane
very
to lift it.
similar.
Yeah.
Maybe a little bit wider because they're a transformer machine, but they are anywhere from 300 to 400 pounds.
Yeah. I mean, this thing actually rolls around really easy.
Yeah.
I mean, we've been moving it
Absolutely.
all around the garage. And it has hooks on it if you have to.
Yeah, if you really have to lift the thing in the back of your truck, you cherry pick or that sort of thing.
I mean,
But honestly,
you
and your buddy?
Yeah, two guys or one of me could probably load this thing in the back of a pickup truck without any problem.
so it's very portable, which actually brings up a point that with it being an inverter, you can use it on you take it to the track. If you don't have 240 at the track,
You can hook it up to a generator.
yeah,
Inverter. That's why it's light too, right?
yeah, absolutely.
Right?
So it makes it really, really good for the weekend enthusiast. A lot of us do racing on the weekend. I know I do. We need welders. We
Yeah,
break
of
stuff.
course.
We
I mean,
gotta
it
get
is.
back on the track.
It is less than 100 pounds.
Yeah.
It's not that.
Absolutely.
It's just that we've got some of those welders that weigh like 20 pounds.
Correct.
So
It's still heavy, but it's
Yeah.
not what you would think it would be. Not what you're used to seeing in a fabricator shop where he's got to push it around, heave it
or
around.
carry it
So-
around with a fork truck.
Yep.
All right. So what else are we going to? Oh, do we have any other questions, Scott?
Right now, I mean, just wanted the dual voltage was a big one. I wanted to see if we could possibly run it on 110, but I don't think we have the power cord out here right now. So
Oh, we can do it then.
It's-
I can run one down.
okay, because it'll run
Yeah.
identically, on that.
Yep. Yeah, and one of the other things we do have in here.
Oh, the question was before I don't mean to interrupt you.
Okay.
Because I forgot he's not mic'd up today. Somebody just wanted to see it plugged in to 110. So I'm going to run down the adapter cord while you're welding some other stuff. But
Okay.
what were you going to say there? I
Oh,
shouldn't have cut you off. I totally forgot Scott's not mic'd up, and I just kept nodding my head like, yeah.
With the adapter, we do show you what you need to be on settings wise for 120.
Okay.
So what people don't know is that welder wants to pull a certain amount of amperage, be able to do with the weld. It wants to. So you can turn it up to the moon, and it's going to ask for a little more than your wall is willing to put out.
Okay.
So make sure you've got a 20 amp breaker if you're going to use 120 volts, and keep it within the parameters. That way you don't hit your breaker.
Yeah. All right. Well, I'm going to let you get back to do some more welding. You're going to weld a couple things. I'll grab the adapter cord, and then we'll wheel this back to the wall, plug it in, show you how long the cables are, because we can make it all better.
So we'll go over. We'll do a lap joint real quick with 3/8. What I'm going to do is I'm going to turn it down a little bit. We'll do a root pass. And that way we're not going to be spray transferring with this. If we were using 45 wire, we wouldn't be spray transferring on the same settings because you're not using as much wire. It's not moving as much metal. So what we're going to do is we're going to do a root pass on 3/8 on a lap joint. I believe we should be set up about where we need to be. It's pretty close. So we're just going to get moving. And what I'm going to do is move over to right in the center of inductance. So that's just, your everyday welder is going to be right in the center. So I'm going to keep it there. And that way we're not doing one thing one way or the other with frequency or with duration of the short circuit. If Joe wants to come on over, I'm going to prep the tip. We're not going to weld super long because we don't want Joe to burn up over here.
While they're getting set up, don't forget, if you got questions, Scott's here to answer them. And don't forget to visit Eastwood.com. We got more information on this. And you'll be able to watch this video recorded on YouTube and Facebook. So now that you guys are set up, I'll let you get back to welding.
All right. If you want to see this, I'm going to clean it up real quick. So what I didn't do is, I didn't go all the way to the top here. I just wanted to do a quick root pass. I didn't want to do any undercutting. This is going to be your base layer, and just to give you an idea of some of the welds you can do, real quick setup, just get in there. I would suggest, since we don't have 45 wire in it right now, just using 35, I did want to do that root pass, and I'd go back over, do a quick weave.
Yeah.
And that way, encapsulate the entire thing basically. Make sure we've got enough material in there to be strong. We do have the, if we did a cut right down the center of this, polish it up, you'd see a real big weld nugget, real deep in there.
Okay.
That's why it's real strong. So, if you guys want to do any other ones, so let us know.
We'll do.
If you want to, do a butt weld.
Do you want to do? Well, what do you want to do on 120? Do you want to do 8th, or do you want to do sheet metal, just to show people that it works on it? It doesn't matter.
Yeah, either way, we can do 8th.
All right, so I'll push the machine back. Got the cord. So this is the cord you get. Oh, it's not that exciting, Joe. There. Let me see. There it is. Woo.
Andy, while you're showing that, how's the spray transfer overhead?
How's the spray transfer overhead?
It still work the same?
Oh.
It does. It's actually better when you want to do it overhead, towards normal welding, because you're not getting showered with sparks, which is kind of nice. But the biggest thing with spray transfer is keeping the same distance from the actual weld itself. So you want to make sure you can do that. Overhead, sometimes you can't get in a good position, so it's going to be a little bit more difficult. But you are able to do that in any orientation as long as you can keep the same distance away from the weld. So if you're good, you can do it. On like tube work, it's going to be very difficult to do spray transferring because you have to keep a really nice, tight position, basically. So with a flat piece like this, pretty easy. Overhead's going to be a little harder just because naturally your arms are going to get tired, but it will work.
All right, so adapter cord. It's this simple. Boom. And then plug it in the wall.
So we'll start this thing up and basically put it at the same settings we would before for 1/8. So that's going to be 22 volts. And
So you don't have to change your settings, even though we change the voltage. It's not a...
No, it automatically swaps over.
Cool.
So what we're going to do is we're going to go to 22 volts. So as you noticed before, at this setting, where I didn't touch the knob at all, we were at 26 volts. Now that we're on 120, it actually changed where we're at. So it automatically kind of doesn't let you go too far.
Yeah.
So what we need to do is we need to be 22, and then, let's see, I might have to look inside the machine. But I believe we were roughly 250, 260. And then we'll do a butt joint real quick on 120. We're going to keep the inductance where we were.
Cool.
And
It's a good thing we got these 15-foot cords for cables.
And we have plenty more to go too. If you guys can see the welder back there, and we're pretty darn far away from the wall, and we don't have to worry about moving the welder all around, grabbing extension cords. With extension cords, you always have to worry about the size wire that's in them. So we have suggestions on thicknesses, gauges of wire when it comes to extension cords. Make sure you get the right ones if you do have to use one. We do sell...
So you lose the amperage on the way?
Correct. If you've seen ours that we have for 240, they're very large.
Yeah,
and then make sure that you don't drop any amperage across. We were doing earlier, we were on a 40-foot extension cord, and we were spray transferring. We weren't losing any, so we were able to do that.
Cool. All right.
So I would suggest if you are doing any welding on 110, probably use 30 wire, but we're going to use 35 since this is what we got it right now.
Yeah, we're live, baby.
Yeah, so we'll get moving right here. And we just blew the breaker. It's live, And what we'll do...
Looks pretty good.
Yeah. What we'll do is... Good amount of heat. So we actually did pull a lot of amperage out of that breaker.
Yeah.
So the heat that we'd use right here, you probably better than an 1/8 inch. So... We
cool.
Nice, quick lines for the heat transfer, so it's a steady machine. The inverter is really having a very steady arc. So,
well, I'll pull this back up. Is that it then for today? Maybe get a few more questions.
Yeah, if there's any more questions, or if people want to see any different types of welds or different thicknesses.
Well, Scott just told me he had one question. A few people have been asking is about TIG if it has a foot pedal.
It does not. This is a scratch start machine. It's something that we've heard a lot of feedback from you guys, and we do want to bring out a machine that would be truly all-purpose and have a foot pedal and do AC and DC.
Yeah.
Because of the way those units are made, they're going to be more expensive. We are working on developing something like that. We hear your comments almost on a daily basis, so we'll get there. We just got to spend the time, R&D, make the right machine for you guys, and we'll bring it out. You guys have asked for it, so we've done a lot of that in the past. We've had a handful of people come to Scott before and ask, "Do you guys don't have a multi-process unit?" We brought out the 200i, and now we brought the 250 because of having the ability to use higher amperage and inductance. people have asked with our current 250, do you have inductance control?
Yeah.
That unit does not. It's more of a portable unit. This is kind of the home shop or the professional unit.
Yeah.
We brought that feature in here because these guys asked for it.
Cool. Any other questions there, Scott? All right.
All right.
Well, hey, when we go, how about we finish up with welding one of the other ones? We'll
Absolutely.
just sign off on that. So don't forget, every Monday, Tuesday, Wednesday, we're live at 3 o'clock at Eastwood.com or Facebook and YouTube. Tomorrow we've got all kinds of metal cutting tools. Me and Matt are going to show you about 7 different kinds of tools. We're cutting everything from sheet metal to 7/8, from plasma cutters to all kinds of shears. Some cool new shears that we just brought in.
So electric shears or manual shears?
We've got,
or all of them?
yeah, we've got electric. We've got our new throatless electric shear, which is pretty cool.
Yep.
We've got our ratcheting shear, which we just showed in a video the other day, plus our standard electric shears, plasma cutter, straight shear, Beverly shear. We're going everything. We're cutting all kinds of stuff tomorrow. And then Wednesday, we're going to, if you price all the promo, Matt is going to be doing some repair on like a Tri-5 Chevy fender. The front fender of it, I believe it's a 56. It's rotted out, so you're going to see English wheel, hammer dolly, all kinds of work. So that's Tuesday and Wednesday, 3 o'clock Eastern time. Don't forget to visit Eastwood.com, check out our mp250i, and if you're just joining us, you can watch this recorded on Facebook and YouTube.
Awesome.
So, all right, let's
get it set up.
one
and
more
let's,
thing as we get out of here.
Let's see.
And if you have questions, don't be afraid to ask them. We try to monitor these videos on Facebook and YouTube for a few days. So even if you're watching it recorded, we always try to answer questions. The best obviously is live because, we can throw the questions to Andy or whoever's hosting and let them answer for you or, demonstrate.
All right.
What were you set at right before we moved the breaker? We want to know.
We were set up at 22 volts.
Probably we have so many other things plugged into that though.
Yeah, so that would work all day long in your normal shop, but if you guys don't see them now, but there's lights everywhere in this shop that are on the same unit. They're pulling some good amount of amperage. Yeah. So it's that's one big thing you got to watch out. A lot of guys call in, they talk to Scott. Have a dedicated line for your welder.
Yeah.
Just because you never know if your buddy's going to fire off a grinder at the same time, or he's using something else along those lines, drill press, whatever it may be. Use the same dedicated breaker for your welder all the time. That way you can get the job done. You don't have to worry about basically hurting overloading a breaker because you've got 20 different things running at the same time. You're going to lose your music, that sort of thing.
You don't want to call in to Scott and have to complain.
Yeah.
You want to call in to talk to him just because you like to hear his voice.
Yeah.
It's so soothing.
Scott loves talking to you guys.
That's why I call him. So, all right, well, let you guys go.